Hey everyone, and welcome to This Explainer. Today, we're diving into something really cool. Whether you're literally studying this for Class 9 chemistry right now, or you're just curious about how our modern world actually works behind the scenes, you are in the perfect place. We're going to break down crude oil and fractional distillation. Yep, we're getting petroleum fractions explained in a way that just makes sense. We'll trace the epic journey of raw crude oil, that thick, black, sticky stuff deep underground, and see exactly how it becomes the fundamental building blocks of almost everything we use today.
So think about this for a second. How on earth does a bunch of prehistoric, buried organic matter eventually turn into the high-tech jet fuel that's powering modern aviation? It honestly sounds like science fiction, doesn't it? But actually, it's just chemistry. There is this absolutely incredible chemical bridge connecting ancient fossils to today's cutting-edge technology. And once you understand that bridge, it totally changes how you see everything around you, from the plastic casing on your smartphone to the cars driving down your street.
Okay, let's dive into this. Part 1. The Deep Earth Origins. To really get this, we have to look at an unimaginable scale of time. Step 1. Prehistoric life dies. And wait, we're not talking about giant T-Rexes falling over. It's mostly microscopic marine plants and animals, plankton, that lived in ancient oceans millions and millions of years ago. Step 2, they die, sink to the bottom, and get buried under crazy amounts of sand, silt, and sediment. Step 3. Fast forward a few million years, and that sediment is now solid rock. The intense heat bubbling up from the Earth's core, combined with the crushing, unimaginable pressure from all those rock layers above, well, it literally pressure cooks this organic matter. It completely transforms it into the dark, complex hydrocarbon soup we call crude oil. And this is exactly why we call it a fossil fuel, because of that ancient biological origin. When an oil rig pumps crude oil today, we are quite literally tapping into millions of years of stored solar energy that ancient plankton originally absorbed from the sun. It's wild to think about, but those ancient biological origins are directly, physically connected to the liquid resource running our modern world.
Moving right along to Part 2, the magic of refining. So here's the core problem. Crude oil, straight out of the ground, it's basically useless. I know, crazy, right? But it's this massive, tangled up mixture of all sorts of different hydrocarbon molecules, all just jumbled together. If you poured raw crude oil into your car's gas tank, you would ruin the engine instantly. Done. So that brings us to refining. Refining is the brilliant industrial-scale solution that unlocks the value of that crude. It takes that messy, tangled mixture and separates it out into distinct, highly useful groups of molecules. And in chemistry, we call these groups fractions.
Now, the absolute magic key that makes this giant sorting machine work is a super simple scientific concept. Boiling point. The temperature where a liquid turns into a vapor? Because crude oil is a massive mix of different sized molecules, they all have completely different boiling points. The tiny molecules, they boil at pretty low temperatures, but the huge, heavy, chunky molecules, they need incredibly high temperatures to boil. So by simply using heat, we can sort them all out.
All right, let's visually scale this thing. Part 3. Climbing the fractionating column. Picture this. The raw crude oil gets heated up until it vaporizes into a massive cloud of gas, and that vapor is pumped into the bottom of this immense, towering structure called a fractionating column. Now, this tower has a very strict temperature gradient. It is blisteringly, intensely hot down at the base, and it gradually gets cooler and cooler as you go up. So as the vapor rises and cools, different molecules hit their specific boiling points, condense back into liquids, and get caught on special trays built at different heights. The heaviest, thickest stuff condenses almost immediately at the bottom, while the lightest, most energetic molecules zip all the way up to the top. Down at that blistering hot bottom layer, we find the heavy fractions. We're talking very large, long hydrocarbon chains with sky-high boiling points. They condense right away. This is where we get bitumen, super thick, sticky stuff. Just above that, we pull out fuel oil, which is this really dense fuel used for massive engines, like the ones in those giant cargo ships crossing the ocean. Oh, and we also get lubricating oil down here, which keeps all our heavy machinery running smoothly without friction. Basically, these are the absolute heavyweights of the crude oil mix. Let's move up and see how this builds. As we climb into the mid-tower section, we find the middleweights. These are the vapors that didn't condense at the bottom, so they kept rising and cooling. Here, the molecules have medium-length chains. First up is diesel, an incredibly efficient, powerful fuel used all the time in heavy-duty trucks and trains. Go a bit higher, where it's a bit cooler, and we collect kerosene. And just above that, naphtha. Now, naphtha is super important. It's a vital feedstock for the whole chemical industry, used to create plastics and synthetic fibers. Finally, we reach the very top of the tower, the coolest zone. These are the lightest fractions, the smallest molecules with the lowest boiling points. This is where we get petrol or gasoline, which of course fuels the vast majority of the world's cars. But here's something wild. Some of these molecules are so tiny and so light that they literally never condense back into a liquid inside the tower. They just pop right out the top as refinery gases. We're talking things like propane and butane. Okay, let's tie this to real life. Part 4, powering the modern world. I just love this contrast. Think about it. On one hand, you've got bitumen, that incredibly dense, heavy fraction from the very bottom of the tower. We use it to pave our roads, creating the literal physical foundation we drive on. On the other hand, you've got kerosene, a much lighter fraction that's used to propel jet airplanes tens of thousands of feet up in the sky. The asphalt stuck to your tires and the jet fuel burning miles above your head started out in the exact same ancient puddle of goo underground. Refining is what let us pull them apart and use them for such radically different things. When you really zoom out, the sheer scale of petroleum's footprint in our lives is it's unavoidable. Those refinery gases at the top, they're the cooking fuels millions use to make dinner every night. The middle and light fractions, they provide basically all of our transportation fuels, cars, planes, ships, trucks, you name it. And the industrial applications are just staggering. Petroleum gives us the base materials for lubricants, waxes, plastics, and countless synthetic materials we touch every single day. It is literally the lifeblood of global industry. But we have to look at the whole picture.
Part 5, the Environmental Balancing Act.
And this brilliantly illustrates a profound trade-off we face today. Let's look at it objectively. On one side, we get immense advantages. Petroleum gives us incredibly dense, easily transportable energy. It's helped lift billions out of poverty, completely revolutionized how we travel, and gave us the materials that built the modern age. But the flip side. Extracting, refining, and burning these fossil fuels releases massive amounts of pollution and greenhouse gases. And those are the primary drivers of global climate change. It is a really delicate, high-stakes equation that our modern society is constantly trying to balance.
Which leaves us with this final critical thought. How in the world will we balance the undeniable utility of petroleum with the urgent growing need for fossil fuel conservation? We are heavily relying on a finite, ancient resource to power a rapidly growing modern world, and the environmental toll is just an undeniable reality. So as you go about your day today, looking at the paved roads, the cars driving by, and all the plastic items around you, take a second to remember the incredible chemical journey those things took, all the way from deep within the earth to your hands. Thanks so much for hanging out with me for this explainer. Keep learning, keep questioning, and I'll catch you next time.